Work through this assigned problem. We have a soda can hanging from a string, and we bring a plastic rod near it. So if this is our soda can hanging from a string, and we have the plastic rod brought near it. Here's our picture. Sorry. Try that again. Here's the plastic rod. We have a distance they give us is, in my example, 14 millimeters. That's how far apart they are. You have a charge on the rod of negative 65 nanocoulombs and a charge of negative 38 nanocoulombs. Two negatives should repel, which means that I should have a force going that way on the can. And that force, according to Coulomb's law, that force should be equal to K, the charge of the rod, the charge of the can, over the distance between them squared. Right? And if I have a force, I have an acceleration, and they gave us the mass of the can, so we should be pretty good to go. So let's move ahead and calculate this force. All right, here I have 9 times 10 to the 9. The charge of the rod is 65 nano, is times 10 to the negative 9. 38 nano is 10 to the negative 9. And my distance is 14 milli is times 10 to the negative 3. And that's in meters, and I need to make sure I square that. So let me break out the calculator real quick. Let's figure out what that force is. Alpha K I have stored as 9e to the 9 times 65 second e to the negative 9 times 38 second e to the negative 9 divided by 14 second e, I missed a 1 there, 14 second e to the negative 3 squared. And again, when you use that e feature, you don't have to use any parentheses because it's as if you wrote in the zeros. So I have a force of 0.113 newtons. So the force on the can is not very much, 0.113 newtons. That's kind of what I would expect, right? Not a whole lot of push. Well, how does that factor into an acceleration? Well, F equals ma. And so the acceleration is that force over the mass of that can. And so that force is 0.113 newtons. The mass is 10 grams. We want kilograms. And so 10 grams into kilograms is 0.01 kilograms. All right, so you divide by 1,000 to get to kilograms. Hopefully that's something you can handle. So if I divide by 0.01, I get 11.34 meters per second squared, which is what my key for this version gives me.